Hello, we are Kutu from Session 7 of SKEE3223 Microprocessor. Our project is Fire Detection System. Fire incidents can occur unexpectedly. It may cause damage of property and loss of life, and many reports highlight that human death due to fire accidents. A major factor is the lack of an early warning system. Without an early detection, fires spread uncontrollably before the action is taken and lead to more serious consequences. To address this issue, we have developed a fire detection system that provides real-time monitoring and triggers alert when hazardous conditions are detected. This helps prevent large-scale damage, ensure appropriate action is taken, and ultimately save lives. This system is built using blackpill STM32F411CEU6 microcontroller, MQ-2 gas sensor module, DHT11 temperature and humidity sensor module, LCD1602 with I2C module, buzzer, and LEDs.
The objective for this project is to continuously detect smoke and temperature levels using the sensors. The next one is to trigger a buzzer and LED when smoke or temperature exceed the thresholds. The third one is to show real-time sensor readings on the LCD display. The fourth one is to utilize the blackpill to process sensor data and control output via GPIO pins. Our project follows a structured workflow divided into 4 main phases. First, research and planning. We start by identifying the problem and selecting our project title. To develop an effective solution, we research existing fire detection system, determine the required components, and design the system architecture. Second, circuit implementation. We study the GPIO pins of each component to ensure proper connectivity with the blackpill. Next, we design a schematic diagram using freezing before assembling and wiring all the components. Third, programming. We write and debug the Arduino IDE code for the blackpill, configuring GPIO pins for sensor input and output device. Next, we set threshold detection, ensuring that when temperature or smoke levels exceed the limits, the system triggers alerts. And last, documentation. We prepare a project report and a video presentation to visually demonstrate our system.
Now moving on to the prototype development, which can be further explained in 3 key parts. First is the power supply. We use 4 AA batteries connected in series with a total of 6 volts to supply enough power to the blackpill and other components. Next is the sensor part. Both of the DHT11 and MQ-2 sensors have 3 pins. The VCC pins connect to 5 volt, JD pins connect to ground, and the signal pins are connected to the blackpill, whereby PB5 for the DHT11 and PBO for the MQ-2 gas sensor. And last, the output part. The LCD1602 with I2C module has 2 power pins connected to the VCC and ground, while the SCL is connected to the PB6 and the SDA to PB7 of the blackpill. Next, the buzzer has the negative pin which connected to the ground, and the positive pin are to the signal of the controller, which is PB8. These two are the smoke detection LEDs, the green LED connected to the PA6 and the red LED to PB9. And these 3 are the temperature detection LEDs. The green connect to the PA9, yellow to PA8, and red to the PA7. Each cathode of the LED is connected to the ground, while the anode passes through a resistor before connecting to the output pins at the blackpill.
Next, let's proceed to the programming part. We use Arduino IDE to code. First, the header file, which will include 3 libraries: DHT, Wire, and Liquid Crystal I2C. These libraries provide simple and easy-to-use interface and communication between the blackpill with DHT11 sensor and LCD1602 module. Then here are the pin definitions for sensors, LED, buzzer pin, and threshold value for temperature. This is easier for us to track, modify pin assignments, and debug. Move on to initialize the DHT sensor by pin and type, and LCD display by I2C address and number of columns and rows. Next, we use two functions, void setup that only runs once, and void loop that runs repeatedly. In void setup, we initialize LCD module and DHT sensor, then configure pins by referring to the pin definition above using pin mode. Each pin is configured with the mode as its behavior, which can be input, output, or input pull-up. This includes smoke sensor pin as input, 5 LEDs and buzzer as output. For the loop part, first read the data from both sensor and store it as integer variable. Then we clear the LCD screen and set cursor to display smoke level and temperature. This if-else statement is for smoke detection logic. The first if statement shows if smoke level greater than threshold, which is 150, the alert will be triggered. Buzzer and red LED will be activated. Or else, in normal condition, only green LED is on. Lastly, for the temperature indication logic, we use if-else if statement. First, if in normal condition, temperature is below the low temperature threshold, 32 degrees Celsius, green LED turned on. Else, if it is in between 32 and 39 degrees Celsius, a yellow LED lights up to show alert. Another else if temperature higher than 39 degrees Celsius, that means that it is in high risk condition of fire, red LED will light up. This system will continuously read data from sensors and gives out output.
This is the hardware build. The two sensors are put inside this box, and this is the LCD that shows real-time reading of the smoke level and temperature. These two LEDs indicate the status of the smoke level, while these three indicate the temperature status. And also the buzzer is placed here. Under normal conditions, the system displays a temperature of 28 degrees Celsius and a smoke level of 68. Both green LED light up, indicating the safe conditions. When the smoke level increases until a threshold of 150, the buzzer activates, and the red LED lights up to signal that a fire incident has occurred. And when the temperature increases until 32 degrees Celsius, the yellow LED lights up, indicating the moderate risk, means need to be alert. And when the temperature continues to rise and reach the upper threshold 39, the red LED lights up, indicating that immediate action should be taken. That's all presentation for our project. Thank you.